In this lesson, we will go through the process of setting up and running a static structural analysis on a simple lattice example using the solid elements method. You can download the starter file below to follow along with this video. Here we have the lattice structure that is sandwiched between two plates, and the lattice and the plates were created as two separate bodies. We also have this material with defined properties, and we want to simulate this lattice with compression load applied to the top plate and fixed restraint on the bottom plate. Let's start by creating a new section called Analysis and add the static analysis block. We'll need to fill out the FE model and the boundary conditions list here. So let's double click into the first input and select FE model. We'll only need one FE component, and we can choose the FE solid component here for this, because we will be meshing this whole structure as one. This solid component needs a mesh, so we'll double click again here and choose FE volume mesh and make that into a variable so that we have everything well organized. I'll name it solid mesh. And we can start to fill this block out with the series of nested blocks for the standard meshing workflow we recommend. So volume mesh, remesh surface, then mesh from implicit body. And here for the body, I'll need to merge the lattice with the plates, so we'll grab the Boolean union block from the search bar and drag in those two bodies, the lattice and the plates. Then I'll isolate this and see that it's all one body now. I'll make this a variable and name it lattice with plates, and then drag it into this body input. Before continuing, I want to make sure that I can freely tweak my inputs in the first block without having to run through the whole workflow. So I'll put the remesh surface block on manual run mode, as well as on the volume mesh block. Now I'll only run when I'm ready to move on to the next steps. I'll start with 0.5 millimeters for tolerance. Let's see what that looks like. And we see here that the edges are getting rounded, so I will need to sharpen it. To do that, I will change the overload of this block to the second option, and then add a sharpen iteration of 1 without specifying the sharpen extent so that it sharpens the entire mesh. That looks better. I'll fill out the remesh block now, and let's start with 0.5 millimeters for edge length and triangle elements. It looks okay, but I want smaller elements, so I'll decrease this number, then click on the play button to run, and that looks good. And if I check the properties, we have now closed and edge manifold true and self-intersecting false, which is what we want. So we can move on to fill the volume mesh block. I'll want to use the same edge length here, so let's make it a variable called mesh size. And drag this in here as well. And then run that. If I select this and press X to see the cross-section, we can see that we have the elements on the inside as well. And all we have to do now is give the FE volume mesh block its last input. I'll choose linear here. And then our solid mesh is complete. So I will collapse this whole block, and then we can also assign that material and start to fill out our load case in the boundary conditions list. Since we know we want a force applied and a displacement restraint, we can have another item on the list, and we'll double click to choose force, and then on the second one we'll choose displacement restraint. And to select the boundaries for both of these, we need to use the mesh that we've just created, so that solid mesh. And we can right click on the face we want to select and choose that flood fill option and bring that into the boundary input. Change to nodes. And the force vector, I will put 0, 0, and -1000 newtons for that force in the negative z direction. And we'll do the same for the bottom face boundary, right-clicking on that mesh face and choosing flood fill, putting that into the boundary input for this displacement restraint as well. We can see that it's already starting to run the analysis because we have everything filled in. So now I'll just start to clean up my workflow a bit by making this boundary conditions list a variable so that it pops outside of that whole nesting block. And I'll also make that FE model a variable and move that up in the order that makes sense for the process, and rename this analysis results. Now if we isolate this block, we can see the result of the analysis, and we can take a look at the cross-section by typing X on the keyboard. We can go to the properties and display and toggle off that wireframe. Using the heads-up display, we can choose to display the strain, stress, and then look at that deformation as well.